So, welcome to my vlog. This is chapter 9 summary. Chapter 9 Transport Layer. Data network and the internet support that human network by supplying reliable communication between people. On a single device, people can use multiple applications and services such as email, the web, and instant messaging to send messages or retrieve information. Data from each these application is packaged, transported, and delivered to the appropriate application on the destination device. The processes described in the OSI transport layer accept data from the application layer and prepare it for addressing. At the network layer, a source computer communicates with the receiving computer to decide how to break up data into segments, how to ensure none of the segments to get lost, and how to verify all the segments arrive. When thinking about the transport layer, think of a shipping department preparing a single order of multiple packages for delivery. This is the role of the transport layer. The transport layer is responsible for establishing a temporary communication session between two applications and delivering data between them. An application generates data that is sent from an application on a source host to an application on a destination host. This is without regard to the destination host type, the type of media over which the data must travel, the path taken by the data, the congestion on a link, or the size of the network. Transport layer responsibilities. Tracking individual conversation. At the transport layer, each set of data following between a source application and a destination application is known as conversation. A host may have multiple applications that are communicating across the network simultaneously. Each of these applications communicates with one or more applications on one or more remote hosts, segmenting data and reassembling segments. Data must be prepared to be sent across the media in manageable pieces. Most networks have a limitation on the amount of the data that can be included on a single packet. Transport layer protocol have services that segments the application data into blocks that are an appropriate size. Conversation multiplexing. Sending some types of data, for example a streaming video, across a network as one complete communication stream, can consume all the available bandwidth. This will then prevent other communication from occurring at the same time. It would also make error recovery and transmission and damage of the data difficult. To identify each segment of data, the transport layer adds a header containing binary data organized into the several fields. It is the values in these fields that enable various transport layer protocol to perform different functions in managing data communication. So the TCP. TCP transport is analogous to sending packages that are tracked from source to destination. If a shipping order is broken up into several packages, a customer can check online to see the order of the delivery. With TCP, there are three basic operations of reliability: numbering and tracking data segment transmitted to a specific host from a specific application, acknowledgement to receive data, transmitting any acknowledged data after a certain period of time. UDP. UDP provides the basic function for delivering data segment between the appropriate application with very little overhead and data checking. UDP is known as a best effort delivery protocol in the context of networking. Best effort delivery is referred to unreliable because there is no acknowledgement that the data received at the destination. With UDP, there are no transport layer processes that inform the sender of the success for delivery. UDP is similar to placing a regular non-registered letter in the email. The sender of the letter is not aware of the availability to the receiver to receive the letter, nor is a post office responsible for tracking the network of the informing the sender if the letter does not arrive in the final destination. So, TCP features, same order delivery and the flow control. Same order delivery because network may provide multiple routes that can have different transmission rates. Data can arrive in the wrong order by numbering and sequencing the segments. TCP can ensure that these segments are assembled into the proper order. Flow control. Network hosts have limited resources such as a memory and processing processing power. When TCP is aware that these resources are overtaxed, it can request that our sending application reduce the rate of data flow. This is done by TCP regulating the amount of the data source transmits. UDP features. UDP features have four types. The data is reconstructed in the order that is received. Any segment lost are not sent. No session establishment. Does not inform the sender about the resource availability. Port number, source port and destination port. Source port is the number of dynamically generated by the sending device to identify a conversation between two devices. This process allows multiple conversation to occur simultaneously. It is common for a device to send multiple HTTP service to request to a web server at the same time. Destination port. The client places a destination port number in the segment to tell the destination server what are service in the being requested as shown in the figure. For example, when a client specifies for 80 in the destination port, the server that received the message know that the web services are being requested. Socket pairs. The combination of the IP address and source port number of the destination IP address and destination port number is known as a socket. The socket is used to identify the server and service being requested by the client. Socket enables multiple processes running on a client to distinguish themselves from each other and multiple connections to a server process to be distinguished from each other. The source port number acts as a return address for the requesting application. The transport layer keeps track of the port and application that initiated the request so that when a response is returned, it can be forwarded to the correct application. Port number groups. Well-known ports number of 0 to 1023. These numbers are reserved from the services and the application. They are commonly used for applications such as a web server, email clients, and remote access. Registered ports. These ports numbers are assigned by IANA to a requesting entity to use with specific processes or application. These processes are primarily individual applications that a user has chosen to install rather than common application that would receive as a well-known port number. Port number groups, dynamic or private port. Also known as ephemeral port, they are usually assigned dynamically by the client's OS when connecting to a server is initiated. The dynamic port is then used to identify the client application during the communication. The netstat command. The netstat command will attempt to resolve IP address to domain names and port number to well-known application. The -n option can be used to display IP address and port number in the numerical form. TCP connection establishment. A TCP connection establishment is a 3-step. Step 1 is step 2 and step 3. Step 1 is the initiating client request to client to server communication session with the server. Step 2 is the server acknowledge with the client to server communication session and request a server to client communication session. Step 3 is the initiating client acknowledges that the server to client communication session. The TCP session termination. So this is the TCP session termination. As you can see, the step 1, step 2, step 3, and step 4. So, all segments have been acknowledged this session. The TCP three-way handshake analysis. The three-way handshake establishes that our destination device is present on the network, verifies that our destination device has an active service in the accepting requests on the destination port number that our initiating clients intend to use, inform the destination device that the source client intend to establishment a communication session on the port number. So the UDP and low overhead versus reliability. So this is the UDP is a simple protocol that provides the basic transport layer function. So the UDP make is very desirable for protocols that make simple requests and reply transaction. For example, using TCP for DHCP would introduce unnecessary network traffic. So application that use TCP. TCP is a great example of how the different layers of the TCP or IP protocols should have been a specific role. TCP handle all tasks associated with dividing the data stream into segments, providing reliability, controlling data flow, and the reordering of the segments. TCP frees the application from having to manage any of these tasks. So the application that choose in the UDP. So that's all for the chapter 9. So I hope you learned something from my blog. And again, I'm Brian J. Asi, so don't forget to subscribe. Thank you for watching and listening. Bye.